So I'm back here. Um,
We're recording.
okay. So good morning and good afternoon, everyone. Thank you for joining us at one more RIST webinar today. I am just here. I'm Susanna Brady. I'm the chairwoman for the RIST Forum. And I'm just in today for a quick second because I would like to take a moment to introduce our host today, Wes Simpson. Wes kindly agreed to host this RIST webinar one more time as he heads to retirement at the end of the year. Wes has been a co-chairman of the RIST activity group and has been one of the main contributors for the RIST initiative since its inception. Once you meet Wes, you're quickly impressed with his knowledge and captivating personality. Over the years, industry colleagues have said so many real things about Wes, and I'd like to mention a few here. Wes is an engineer, a marketeer, a manager, an author, a product expert, an event organizer, a speaker, a journalist, a contributor, a consultant, an excellent writer, and so much more. Wes consistently demonstrates that he's an industry expert in video transport over IP, contributing to many diverse projects worldwide and authoring several very informative books. Wes has the ability to conceptualize and effectively communicate a new product or application in a way that brings positive attention and realizes the product a very productive result to any project that he contributes to. As far as technical skills goes, Wes' ability to translate complex technical concepts into easily understood prose is unparalleled. His knowledge of video over IP is legendary in the broadcast industry, and we can only say that we've never heard a question in this area that Wes did not know how to answer. Wes understands emerging technology in broadcast and stays on top of everything all the time. His easygoing personality and passion for high technology have made him a good friend and colleague in the industry for many over the years. He's a valued resource to many in telecom, telco, broadcast, pro AV, and multimedia industries. And somebody said, what's something I thought about this before, he has been appropriately called the Renaissance man in this industry. So the Video Services Forum, the VSF, and SMT, by the way, he's a SMT fellow, RIST, and many other industry organizations would not have been the same without Wes. So the RIST Activity Group and the RIST Forum today greatly appreciate your contributions, and we're going to miss you every week on those calls and those discussions as you head to retirement. And just want to say thank you very much from all of us.
Susanna, you're very kind. There's a Yiddish word for verklempt that I think applies here to my emotions. Thank you so much, and thank you to everybody. I'll still be lurking. I'll still be diving into the weekly calls when I can, and retirement basically means for me I'm just going to be doing volunteer stuff. I'm not doing any more. No more invoices is the rule. So we'll see how it goes. Thank
That's
you so much.
awesome. Well, thank you. You're the best.
Okay, take it away, Wes.
All right. So what we're here to talk about today is the emerging specifications produced by the Video Services Forum called the hybrid satellite um, internet technology. And the idea here is that we're trying to make sure that satellites can perform to the mission that we've assigned them and deliver a very reliable signal regardless of the weather conditions or other impairments and things like that. And it's becoming a much bigger issue. And our first speaker, Rick Ackermans, who's the chair of the RIST AG group, is going to start out by laying out for us the impressive need in his organization for this technology. And I think what we'll do is I think we'll just let's just preview the rest of the agenda. We have a couple people diving in deep to the technology, both Ciro Noronha from Cobalt Digital and Adi Rosenberg from Alvalinks will be focusing on how the RIST technology is going to be able to support the valuable satellite transmission. I'm stepping in to give a presentation on behalf of Richard Rollins. Unfortunately, he was unable to make it with us today. We hope he's doing well. And I'll take over and give his presentation. We'll have a service provider perspective from Ruben Calzadia, who works for SES, talking about how this technology can improve their delivered product. And then we'll have two manufacturers on board, Alan Young at Zixi and Sergio Amarata at SipRadius, to tell us how they're making progress in delivering this technology. So without further ado, take it away, Rick.
Thank you. Let's go to and share. Hopefully you are seeing my full screen presentation.
Looks
are you?
good, Rick.
Yes, we are.
Looks good. Okay. So I am the chair of the RIST activities group. I'm a VSF board member, and I'm also the director of RF and transmissions engineering for the CBS television network. And largely what I like to do here is give a user's perspective of some of the challenges we are facing at CBS as just a representative user. So the FCC will reduce and might eliminate C-band satellite. So the FCC has issued last week, this was last Friday, its report and order. So it came out on Friday, December 5th, 2025. It's part 47, CRF parts 1, 2, 25, and 27. And the key part here is the line where it says that the notice that the FCC is given the wireless services in the 3.7 to 4.25 gigahertz C-band spectrum, making as much as 180. That's effectively everything that's left, except for a small part that has to stay for aviation. And at least 100 megahertz of the 3.98 to 4.2 gigahertz band, upper C-band, available for terrestrial wireless flexible use, as per the One Big Beautiful Bill. What this means is that they will auction off at least 100 megahertz and possibly 180 of the 200. 20 megahertz remaining is useless. So C-band has a real possibility of totally going away. This is very real. This is happening. And this is as per federal government. Now, what I get confused at sometimes is I have people come up to me who really honestly, and these are engineers, who think, what, you're still using C-band satellite? Isn't everything on the internet? And I've had some really smart engineers who obviously don't do transmissions, but who truly honestly think we're not on satellite anymore. And that couldn't be further from the truth. The answer to that is no, we do not use the internet. And here is a snapshot of what CBS currently does today. This is showing all of our downlinks, and this is half of it, because we do everything times 2. So we have every single feed on 2 satellites, and there's 2 dishes at every affiliate. This is today. This is updated as of last month. So this shows how much we absolutely, totally rely on C-band satellite. Now, people ask, what did CBS do before satellite? Well, setting the Wayback Machine, here's a snapshot of what we used to do using microwaves back in the early 1980s. Not exactly something we want to go back to, but it's just a snapshot of the way things used to be before satellite. And as you'll notice, there's no redundancy in this retro view. Something goes down, you're done, you're gone. So it's amazing anybody out west, not at the extreme West Coast, because West Coast had separate playout, but anybody in the mountain time zone ever got to watch television, I find truly amazing. So why not use KU or KA or Starlink? Well, first of all, let's deal with Starlink. Starlink is KA. So when you say KU or KA, Starlink is KA. And KU and KA don't work in heavy rain. Here's a snapshot from last Friday from Florida. and you can see over the Tallahassee area, there was a whole lot of rain. And if you have heavy rain, KU and KA do not work. So if C-band goes away, why not just use the internet? Well, we've done numerous analysis, and even with RIST, as great as RIST is, internet connectivity does not have the reliability of C-band satellite at comparable price points. Can you make it very reliable? Absolutely, you can, but it will cost you more. So what are the options? That's why a hybrid satellite internet solution is needed. And that's why, you know, we are pushing RIST hybrid satellite. I'm not going to get into the technology of RIST hybrid. There are plenty of other folks here today to do that. And so I was just teeing up why, as a broadcaster, we need some solution. Okay. Back to you, Wes.
Thank you, Rick. If you stop sharing, that'd be great. And yeah, so speaking of manufacturer perspectives, we're going to jump over to Cyril Naronia, who's going to give us a view of the technology. In specifically, Cyril was the author of the hybrid satellite part of the RIST specification within the Video Services Forum. So he's going to lead us through exactly how this technology works.
Thank you, Wes. I'm the guy who wrote it at the end, but this is a group effort, right? So everybody contributed, and G. Rosenberg, who comes after me, was one of the first ones to actually deploy this. So I'll give you a technology overview of hybrid satellite. So satellite is the best to send the same content to a large number of recipients that are geographically distributed, except when it doesn't work, right? So rain fade is, as Rick indicated, is a big problem for the KU band. We now have the internet, we use it. So can we combine both? So the idea here is let's do the heavy lifting through satellite, and then we use the internet to fix the holes. We resend lost data, and guess what? RIST already has the mechanisms to do that resending. Can we just use the internet? Yeah, but you have to have one individual copy to each destination. That costs money. For each destination, there's an ongoing OPEX cost. You can pay a CDN, but then it gets pretty expensive. And if you're doing satellite now, you have to retrofit all your sites before you can do internet distribution. So may or may not make financial sense to depend on the number of destinations. And as Rick indicated, it can be made to work, but it's going to cost you. It's going to cost you. So this is what we do. We send the transport stream that goes to the satellite. It's the same transport stream. We add some data to it to allow for the recovery, but it's backward compatible. So once this technology can be deployed gradually. You can deploy it gradually, and legacy sites who don't understand it, they just continue to work the same as they work now. So this thing here, the processing tab, adds a backward compatible metadata to receive and identify the lost data. So that's the key point, right? You add some information to the transport stream so that the people who know how to use it can request the lost packets. This is in Video Services Forum TR-06-4 Part 7, which you can download for free in the Video Services Forum website. I am not going to bit sniff this thing. The technology details are all there. I'm just going to give you the highlights. So why do we do it over here? RIST, it's the ideal protocol for recovery because it's based on standard RTP. It's natively one-to-many. It has consistent sequence numbers, between primary and backup servers, between satellite paths, including you can even do something like a -7, seamless redundancy between internet and satellite if you want with this. Other protocols such as SRT do not lend themselves to this application. RIST is natively capable of doing this. So does it work? I mean, Sergio West was going to present the thing from Caritech that has this deployed, but we also had a demonstration at NAB New York between Cobalt and Zixi, independent implementations of the standard of the, I'm not allowed to use the word standard, the specification, where we had a Zixi sender with the markers going to a satellite modulator. The Cobalt gateway is just a translation, and we send L-band to a legacy IRD, and this was dropping packets, this is dropping data, right? The same, the ASI out of the legacy IRD, there was just the demodulated signal went to a Cobalt decoder that had this technology. So off of the same ASI, we had perfect playback here and glitchy playback here. So that was running, and that was interoperable. And again, with the TR specification, Zixi developed independently of Cobalt. We did not share any code. We just plug it in and it worked. You can enhance hybrid satellite with program selection, which is another VSF TR, which is TR-06-4 part 6. Normally, a headend will send a multi-program transport stream. If you don't need everything, there's a method to just get what you need. So in the case of a network like CBS, for example, you may have a whole feed, but different sides only need parts of the feed. So you can tell the sender what you need and further optimize the internet bandwidth. So these parts of RIST all come together and allow you to efficiently recover the information and optimize the internet bandwidth. And that's my high-level discussion of this. Next on.
Thank you,
Yes,
Ciro.
Wes.
Thank you, Ciro. I appreciate that. We'll be having everybody on board here to do Q&A after all the presentations are done. So Ciro, you can stop sharing. And we're going to switch over to Adi Rosenberg. Go ahead and bring yours up, Adi. Adi is the founder and CTO of Alvalinks, and he's going to be talking about how this technology, which he helped create, how the specification, how this technology works in a non-perfect internet environment. So go ahead, Adi.
Thank you, Wes. Thank you, Ciro. So I'm going to talk about something else, which is, sorry, not something else, but a different approach, which is a hybrid broadcast and internet. And this is something that came out of the discussions and the work we did at the activity group. And the idea that we wanted to achieve was to go the next step forward, to look what can we use the likes of Starlink, KU band, or anything else that can carry IP packets, not limited to transport stream packets, but rather IP packets across, and can we achieve some kind of a better recovery? Some techniques like satellite, ATC-free, DTH, EMMBS, which is common in the mobile communication. We wanted to allow seamless switchover between unicast internet feeds to a broadcast alternative in case of a network overload. Imagine you have the Super Bowl. You want to switch from reception on one medium to the other without having any interruption, no additional delays. You can onboard multitude of users at once using something like ATC-free as an example. But we want to have it in over any condition. So if there are any packet loss or the need of recovery, we can still provide a pristine feed to the receivers. We also thought, why won't we be able to augment and personalize broadcast feeds with targeted advertising? If we know exactly what the audience sees, we can then slice in additional data, additional augmented data that might be personalized and improve ad insertion. And at the end, the use of internet to recover broadcast interferences, as we mentioned before. So mind you, this is talking about IP over broadcast, not transport strips. So in this example, IP traffic is going to a modulator, going to a tower, which can be like an STLTP, it can be a ATSC-free tower, it can be DVB-S2 using GSE, it can be IP traffic going over MPE, and that traffic is basically delivered to the end users. This is common in a lot of parts of the world, also ATSC becoming popular in the US. And with this approach, with this technical recommendation, what we can do, capture those IP packets if they are encapsulated into RTP, and using RIST to recover the packets. So then anything being lost, we can recover, or we can augment and add content using the internet wherever we need that on a unicast basis. So some use cases that I just mentioned, for instance, allow spread of traffic between internet and ATSC for high-profile events like the Super Bowl, instead of scaling up to a CDN every time, which adds a delay, adds more expenses to the providers, allow fast recovery of local interferences affecting broadcast services, satellite AC, MMBS. Imagine that you have a sport event stadium where you have feeds coming over your mobile cellular, which usually is a multicast. You can then send that as an RTP, recover that on a unicast basis on a mobile by mobile device using this technique. Automotive media. Imagine the future where you are riding in your car, there's Wi-Fi 6, maybe Wi-Fi 7, you have a Starlink coming in. If there is an interference packet being lost, you can then recover that using a unicast per mobile device so that the stream is pristine without any hits and you can switch over. One of the known problems of Starlink is the switchover effect. If we can recover the switchover effect from automotive, then you can still see movies without that buffering while you're switching beams of Starlink. And then you can create differentiated services. For example, pre-over broadcast, where you do enhancement like HDR using the internet for paying customers. This is something that is being tried today in continents far, far away that are provide free services and enriched content using such techniques. Baseline over broadcast and voice over metadata over the internet, so it enriches and augments the content as an enhancement. So sport events, you can see, you can hear more commentators, you can hear more services coming if you are paying a customer and you pay to receive those. And as I mentioned before, target advertising using internet over broadcast feeds. Now, just like Ciro said, why did we select the RIST instead of SRT as an example? And RIST is based on a standard RTP, means that the sequence numbers are maintained continuously. While in SRT as an example, every session, the sequence number changes, so you cannot maintain coherency of sessions. You cannot have sequences running over the broadcast and recovery SRT over the unicast because they will have a different sequence number, so it will be very hard to recover that. Then most broadcast services do use RTP over multicast, just like ATSC-free. For instance, STLTP, ALP is covered, is delivered using RTP multicast. So it's easy to recover that using RIST because it's native. Same goes for MMBS. Those are multicast feeds that can carry RTP. So as Ciro mentioned, it's native multicast support, consistent sequence numbers across, consistent sequence numbers between primary and backup servers. And that is the reason why We chose RIST, and that is why it appears under the RIST forum and not RIST forum and RIST activity group. And it will be very hard to implement with an SRT implementation. Thank you. These are my contact details if you want to reach out and ask me questions.
And again, for those of you who are paying attention, Adi is going to be here after we get done with these presentations to answer questions if you have any. So feel free to stick around for that. So our next presenter is actually me. Unfortunately, Richard Rollins was unable to join us today. So I'm going to take over for him and share my screen here and talk about an actual application for the hybrid satellite that has been installed and is actually working today. So, an operator's journey. Okay. So, Caritech operates a Ku-band satellite platform carrying over 100 channels across the Caribbean. So they've already been doing this for quite a while. The signal's in the sky. They deliver it to hotels, also known as commercial head ends. That's their primary customer. And they also provide a direct-to-home service for some residential customers, again, across the Caribbean. The issue is that because they're in the Ku band, they need to be working with satellite frequencies that can have impairments. So how do they go about upgrading that? So today they have their head end. They transcode things into RIST. They basically packetize transport streams. They use RIST to deliver these things to a hotel head end, and the hotel then delivers those packets to the guest rooms. Okay, it works great. You have reliable delivery because of RIST's built-in ARQ packet retransmission technology. It worked across many different levels of internet quality. No packet loss was available to the guests, and it's simple to deploy and manage. And again, just delivering this to a hotel, and then the hotel redelivers that to lots of different guests. And again, the hotel could be using an IPTV system. The hotel can be using a standard broadband cable system. Whatever, any transformation can be done in the hotel head end. But what happens when you scale? Well, because the internet is unicast, you have to create a new stream from your head end to each new customer that you add. Okay. And the question is, why are we doing this? We're already delivering a very nice signal to all these locations using the K-band satellite. Why can't we just use that existing signal? Okay, so it's already there. It solves the scaling challenge. As you get more hotels, they have no impact on the satellite signal. You just have more receiver locations scattered across your satellite footprint. And, why don't we just have the satellite deliver that content directly to the hotel and eliminate the IP delivery leg entirely and go to that. So, the current, the head end sending out individual IP streams to each hotel. When you convert that over to satellite, all hotels get the same stream from the satellite simultaneously, and it scales infinitely. The problem, of course, is rain fade, as Rick so eloquently introduced us to that concept. If you have a heavy rainstorm, that can block the signal coming from the satellite down to these Ku band receivers. And even with a professional Ku band receiver, a larger dish than what you might have for DirecTV or something like that, even that won't solve your problem. You don't get enough gain out of that satellite receiver to be able to overcome the impairments that are happening due to these rainstorms, okay? And the commercial customers are more demanding than the direct-to-home consumers. If the direct-to-home consumers, they're paying a few dollars a month for something. If it goes out, it goes out. The hotels want to provide something to their viewers at all times. They want a highly reliable service. They're paying for a higher quality delivery. And if a hotel guest is stuck in their room because it's raining outside, what are they going to do? A lot of them are going to turn on the TV, see what's on. And if the TV's out, they're going to be mad. They're going to call the front desk or whatever. So what we need is a trade-off. We have to work RIST over IP. We want to use that for its better quality during rainstorms and things like that. It's very reliable, but we don't want to have to add incremental cost every time we add a new receiver. With pure satellite, it scales beautifully, but we have these rain fade interruptions. So what CaribeNet really needed is a hybrid solution: scalability of satellite, the reliability of RIST. Well, satellite hybrid, that's exactly what we're talking about in RIST Part 7. So you have normal operation. Your hotels will be getting their signals from the satellite. Rain fade, they switch over automatically to the RIST link over the internet, and when that rain fade goes away, you can seamlessly go back to the original feed. So the result, which is installed today and working for a number of high-profile customers at CaribeNet, is satellite hybrid using the RIST Part 7 technology. So what's the beauty here is that you don't have to choose. You can have one hotel be served via the internet exclusively. You can have another hotel or direct-to-home customers that are served exclusively through the satellite. And those solutions can run simultaneously. You only have to provide backup for the customers that need backup. And that's one of the things that's being contemplated is let's move on from just using satellite for some viewers, offer them a higher tier package, put a low-cost appliance in their homes that can do their recovery just like the hotels do using RIST Part 7, and maybe charge them a little higher price for premium service. So if you have a full outage, you can recover that with RIST exclusively. If you just have a rain fade that's coming in and out, you can mix and match packets from the satellite, packets from the recovered IP stream, and you don't have to give up reliability to gain the scalability and the cost benefit of the satellite delivery. So residential direct to home, we're going to produce a lower cost appliance that a consumer can use, and they're already getting the KU band. Now all we need is an internet connection, and boom, they might be able to they will be able to have a seamless delivery. We can also do out of band applications. We can start looking at things like ad insertion, where in the satellite delivered to a hotel, maybe you can offer advertising to local businesses that want to advertise just on a single island in the Caribbean. So the possibilities are endless. So they started with RIST over IP to commercial head ends. It works great. They've upgraded that to satellite delivery. It's installed. It works. We've got our customers are very happy, or the Caritech customers are very happy with this. The key takeaway here is that this solution, it will work for both satellite and home delivery, and our RIST delivery. Everything can very nicely play together. So take your questions at the end. I will stop sharing, And we will switch over to Ruben Calzadilla, who is with the satellite company, SES, and has a lot to say about how this technology works in a real environment. Take it away, Ruben.
Thank you. Thank you, Wes. So, what we are up to, well, my name is Ruben Calzadilla, and I am a Senior Technical Advisor at SES. And this presentation starts with a hypothesis, not a conclusion, not a statement. We're asking whether Ku-band combined with the BSF TR-06-4 Part 7 and constrained to packet recovery only can deliver services that resembles that of C-band. I know that may sound crazy, but we're seeing indications that this is something that is worth exploring. So that's what we're doing. Our goal is to evaluate the mechanisms, validate the assumptions, and see how close the hybrid systems behave as it compares to C-band. As we were already hear from the experts here, so there are two operating modes on Part 7. I'm going to call Part 7 from now on. One of those is the packet recovery mode, and the other fail-safe is the full stream recovery. So if something gets completely dark, there is the option to request the full stream. But we are constraining ourselves here to packet recovery only. As it has been mentioned already, I think multiple times, the problem is rain. And in Florida, in this case, as you can see, Florida is around here. They get about 80 millimeters per hour, and that it is enough to basically knock down the KU satellite completely. It's not like C-band doesn't get impaired, but it gets less, obviously, than C-band. So what is that we're trying to see? What is the objective? Well, we're trying to see if we can deliver that C-band-like service using KU plus packet recovery only with some design principles. Again, the idea is to reduce the contention ratio of the internet by not dumping traffic that is not needed all the time. And we think that this architecture will help us achieve that. So as you see on the upper part, there is a broadcast channel, which is the satellite in this case. And at the bottom, we have the recovery network. And the recovery network is actually divided in two sections. One is completely managed from the processing tab that Dr. Zero talks about to our core edge. And the idea is that we're trying to reduce latency or control latency on this section and reduce the overall latency in order to make those buffers at the gateway as small as possible and still achieve seamless packet recoveries. And if you are obsessed of availability, as we are, high availability isn't about building two versions of the same thing using the same infrastructure. It is about diversity. So satellite and terrestrial networks fail for completely different reasons. So when you combine them, their failure modes no longer line up. That independence is what the hybrid model is so reliable and efficient. There are some key optimizations that we like from Part 7, and I think everybody have talked about them already. One of those being the ability to select the programs that you want to recover. So any sites that is not interested in recovering some of the programs, they can decide to do so, putting less pressure on the last mile connectivity, right? That's one of the objectives. Understanding the problem is important, as well as understanding how the L-band demodulators work. So we collected 4 years of rainfall data from the 3 permanent NOAA weather stations in Florida, one in Melbourne, in Miami, and Tampa. The goal was to basically get an idea of the regional behavior of rain fate. And the graph on the left shows that something very important. Rain in Florida does not occur uniformly across the state. Peaks happen at different times in different regions. For a recovery network, for designing that recovery network, that means that we do not need to design capacity if the entire state is experiencing the worst case range simultaneously. Instead, we design for the worst affected region. That same network will comfortably support the others because they rarely overlap. On the second graph shows the seasonal pattern of the rain in Florida. The real stress period for KU band is concentrated between May and October. That doesn't mean that there could be events like Rick show from last week in Tallahassee, but they mainly occur during this period of time. So that gives us the opportunity to plan for seasonal scaling. For instance, if we add more resources during the month where recovery traffic is statistically high and scale down when it's not. Now, to understand where Part 7 actually operates, we need to look at the L-band DBS2, the modulators, and how they behave. The graph shows three distinct regions, and we're going to go one by one. So this is the first region. This is the region where there is plenty of SNO, and the modulator can basically, using the inner and outer FECs, can correct all errors. And the output of the TS is clean. So this is great. Everything is working fine. So that first region has a threshold. The threshold is the quasi-error-free threshold that is right here. There is another threshold that is not commonly mentioned on vendors, that is the loss lock threshold. And that is important for us because that will define that precise region where the recovery packets happen. And that we want to concentrate on that region. We want to understand how that region behaves and how we can maximize that window. And on the specific mod cost that we have here, 72 megabits per second, we measure that we probably be getting about 10 megabits per second per transponder for recovery traffic. That is a huge reduction. If you have, if you are receiving multiple transponders in your site, if you're an MVPD, for instance, that will mean that instead of having to design that last mile for peak bit rate, it's just a fraction of it. So that's what we're trying to understand. And the last region is the full stream recovery region that we call that operating mode of Part 7. And basically what happens is the modulator carrier carrier lock, and there is nothing to repair. Basically, the only way that you can get the stream is by requesting the full stream. And the question for us is, how can we expand on the packet recovery region only? And we found that, or we observe as well, that when enabling pilots, it improves the stability of the carrier timing and phase tracking loops into the modulators during fake conditions. So if you don't know what pilots are, they are small reference signals that are inserted in the modulated waveform to help the modulators track the carrier's frequency and phase. They usually carry about 2.4% overhead. And you can think about them like the reflective markers on the road. When it's foggy and dark and you're driving, those markers help you stay on your lane. Pilots do the same thing for the demodulator. In practice, the modulators remain locked deeper into the fade when pilots are enabled. And this is the region that we think we can gain about 0.5 to 1 dB of recovery packets. So we have a question mark here. Now, what do we expect as test results? So we expect the C-band will remain locked longer, but with rising packet errors. We expect the KU plus pilots per Part 7 will hold perfectly clean pictures until true loss of lock, basically creating the true cliff effect. So perfect zero. While C-band will cross that QF threshold at one point, while we expect to still see clean KU pictures and continues to deteriorate until C-band will lose lock. We expect that there is effective service availability close to C-band with around 1 dB gain in usable margin. And this is a rendering of what we think it could look like. And we will be happy to share this result with the community as well. Thank you.
Thank you, Ruben. I mean, I can tell that you've been doing satellite stuff for a long time. You are a true master of this stuff. So if you go ahead and stop sharing your screen, we'll switch over. Our next presenter is Alan Young from Zixi, who has a very long and illustrious history of very high reliability links. And he's going to be giving us a established manufacturer perspective on what Part 7 can do for his company's technology and his customers. Go ahead, Alan.
Thank you, Wes. Okay, so I mean, we've talked a lot about this today already, but today's delivery of media to TV stations and cable head ends basically relies on C-band. Rick mentioned it right at the start. And it's universally used by broadcasters and cable networks in the US. Pretty much everyone uses it. And there's a reason for that. For basically 50 years, C-band has proven to be phenomenally reliable, especially when dual satellites are used. And all of the major broadcasters use 2 satellites to deliver their content to the TV stations in particular, and also to cable head ends. And so, we've also discussed why alternatives are required. The FCC issued, well, they put it on the Federal Register, a notice of proposed rulemaking, and that is for a minimum of 100 megahertz of the remaining 220 megahertz of C-band spectrum. And that has to be auctioned by July 2027. It could be as much as 180 megahertz. And so that's open for comment. Comments are due on that on January the 5th. Although the National Association of Broadcasters a couple of days ago requested a 30-day extension to that, because I guess, we're in the holiday period. So, people don't want to be spending their holidays writing comments on, a 65-page notice of proposed rulemaking, I guess. They've got better things to do. During the whole process, which has been going on since February, the biggest concern raised by media companies was the lack of reliability of terrestrial-based delivery. And the reason for this is a lot of TV stations and head ends are in rural areas, and there is either a lack of diversity of providers with enough bandwidth, or in quite a few cases, there's only a single physical duct, like a pipe going into the building. And of course, if that duct is breached in any way, you lose access to all the utilities. Now, they've got generators so they can stay on, keep the power on. But, if they lose a fiber connection and it's a single thread fiber, if both fibers, if you've got 2, go through the same duct, you're gone. Not a problem with satellite. All the big ones have two dishes. And so they can keep going. And so the net result here is that if you want the same level of reliability that you get with C-band and the same level of quality, you really need a wireless solution at the present time to go along with a terrestrial solution. And so Zixi is focused on making as many options as possible available and configurable so that you can indeed get a reliable connection in the post C-band era. And as Rick said right at the start, we are now in planning for a post C-band era. There's no question that we're going to have a vastly reduced amount of C-band, no matter what. The question is, what does the industry do about it? There's another reason as well, and that is as the demands for higher quality and more regionalized, localized content increase, there's going to need to be more capacity provided. And quite honestly, C-band is not in a position to do that today, even with the 220 megahertz that remain, and certainly that's not going to get any better. So there's a need for alternative solutions. And so those alternatives, well, basically I could categorize them into four compartments: terrestrial ISP/dedicated fiber, Ku band satellite, low Earth orbit satellites, and ironically 5G wireless is also a usable alternative. And these options all have their own advantages and disadvantages. I mean, one of the biggest advantages of Ku band satellite is for the broadcasters. I mean, they've been using satellite for 50 years. They're changing the frequency band. So all they have to do to make use of Ku band satellite is change the feeds on the antennas, which is not a monumental task. And we've discussed the issue with the rain fade or attenuation that's caused by precipitation, and there are solutions to it. However, that doesn't work necessarily for everyone, and so solutions to a terrestrial pipe using LEO or 5G are also necessary. And so Zixi is focused on providing capabilities for all of these. But to simplify things, because not all receive sites are created equal, we believe that a combination of at least two of these alternatives are going to be required, and they're going to need to be combined in a way that allows auto packet by packet switchover between the alternatives automatically on a receive site by receive site basis. And in order to do that, there's a range of tools that are required. We've talked a lot about the technical recommendation 6 part, -4 part 7, hybrid broadcast and unicast. Ku band could give a ubiquitous coverage in the United States, and as each individual receive site has a problem with rain fade or whatever, you can pull those in via a unicast IP connection, and that absolutely solves the Ku band rain fade problem. But there are other tools that are required as well. So we need the automatic repeat requests and the forward error correction. And we need to be able to dynamically adjust those depending on the performance of the links. This is something that Zixi specializes in. SMPTE 2022, not 2002, 2022-7 hitless merge probably should be used where possible, because you have a hot path, and then so on a packet by packet basis you can select which one works, and as long as you get the packet from one of the paths, you're good. Of course, it requires RTP support, as was mentioned, and so RIST and the Zixi protocol obviously support those. There's also bonding of multiple ISP connections that are required. So sometimes an ISP can't provide enough bandwidth or enough quality, and so it's necessary to bond multiple connections together to create one logical connection, which would then be one leg of a 2022-7 hitless merge situation. And latency management. And latency is an important thing, particularly for the broadcasters. Not so much that they want it to be really low, because everybody does. And a quarter of a second is, pretty good and quite challenging for any other technology. Still possible, of course. But broadcasters sometimes want the latency to be exactly the same across the entire United States. So they, with 6 o'clock news needs to start at 6 o'clock or 3 o'clock in Los Angeles, but it needs to start on the hour on time. So the latency needs to be configurable so that it can be, made to be equivalent to a satellite. Because with satellite, that latency problem is kind of solved because the signals, all, just because of the physics of the matter, they all arrive within 10 milliseconds of each other anywhere in the United States, which is less than a frame. So we need to be able to create that functionality as well. And so Zixi's platform is really designed to support the standardized hybrid solutions. So the RIST satellite hybrid, we support that. As Ciro mentioned, we worked with Cobalt to demonstrate that at NAB New York. We've added the capability to either bond with or switch between LEO and 5G connections, and that's done on a priority basis. So, we'd only pull packets from the LEO or 5G when the normal terrestrial or other link doesn't work. And the reason for that is cost control. So, it's quite expensive to send over these LEO and 5G systems. They basically charge you by the gigabyte. Terrestrial ISP and/or dedicated fiber. We believe in multi-protocol support. So, Zixi protocol, SRT when needed for compatibility, RIST if you need it for, a hybrid satellite. We believe in providing the maximum flexibility because, as I said earlier, every receive site is going to have its own set of circumstances, and we want to ensure that users have the ability to configure their last mile alternatives in as flexible a way as possible. And the whole thing would be managed and monitored through Zixi Zen Master, which is essentially a single pane of glass that monitors the whole thing and configures the whole thing for each receive site. And again, lastly, software that runs on COTS, and if existing IRDs need to be supported, we have an SDK to do that. Thank you.
Thank you, Alan. Appreciate your manufacturer's insight, and we've got one more that we want to sneak in under the wire here. Sergio Amarata, the chief scientist and founder of SipRadius, is going to talk about some of the solutions he's already delivered using RIST Part 7. Go ahead, Sergio. You can share your screen.
Excellent. Let me share my screen real quick. And here it is. Everybody can see that. I'll start.
Looks good.
All right. Well, hello. I'm Sergio Amarata. I'm the chief scientist at SipRadius. And at SipRadius, we build the hardware and software environments for professional broadcast streaming, including this hybrid workflows we're all talking about here. So hybrid satellite and IP workflows sound great in theory, right? We've seen so many talks about what it's supposed to be, how it's supposed to work, but we're really asking hardware to do things it was never designed to do. And I'll go over some of those challenges and how we were able to overcome them. When we say hybrid, we mean combining two different environments in this case, satellite and public internet, or perhaps wired and cellular, or wired and wireless networks. One is stable and predictable, the other one is not. So what happens when we try to make them work together? Well, manufacturers face new challenges that traditional devices and hardware aren't built to solve. So this is not about tweaks to legacy hardware or RERDs. It's about designing new systems to handle these problems. And that's what I want to explain today. What does this mean for hardware design? So legacy hardware equipment was never built to do what we're asking it to do. So when we talk about hybrid being the future, we're talking about big changes in the way this legacy equipment needs to operate and the way it needs to be built. For one, hardware needs to now operate independently. It can rely on the network and it can rely on the satellite to behave perfectly anymore. And the designs need to assume that variability will be the norm, not the exception. When you test prototypes, you can't just check that they work in ideal environments and put some brain fade and that's it. They need to be ready to adapt to the unpredictable conditions we'll see in real deployments, as you saw with all the graphs, rain fade, and other types of anomalies over the regular network, backhaul. And as you scale up, hardware has to maintain consistent performance no matter how different each site is. That is the challenge. So this slide really captures the heart of the challenge we face as manufacturers, or we faced as manufacturers in hybrid workflows. As you see, satellite IP environments are not just difficult because of the network complexity, they fundamentally reshape the role of hardware. Each of these elements that you see here in this graph has direct impact on how you design the solution, how you build it, and how you deploy it. One, timing instability. Hybrid paths break traditional timing protocols like PTP or NTP. You cannot assume that you're going to be able to get it either from the network or the satellite. So devices must generate, a good device must generate their own timing reference rather than rely on the network. And why is the timing so critical? Because you need to be able to deliver the signal at exactly the same time in every location. And that delivery now needs to have an additional buffer that didn't exist before. And unless your timing is perfect, that buffer could be different from site to site. That's why the timing is so critical, and you must have a way to generate your own time. Two, the OS and stack. Hybrid systems introduce unpredictable jitter and latency. So manufacturers need to optimize OS layers to handle this instability. Three, recovery workloads overwhelm standard devices that are not built for packet level correction. For example, FPGAs, which is what most SAT receivers have on. Now, RIST helps, but it requires really specialized hardware to manage retransmissions efficiently. Specialized hardware, regular CPU stacks, Linux, buffering, RAM, that type of thing. Four, hybrid recovery paths often involve public internet, right? So security models must adapt to protect content. I think that was one of the things that was overlooked in a lot of these presentations that we've seen, that for this system to be widely adopted, the hybrid recovery, the implementation of this hybrid recovery must preserve the DRM, requiring solutions that operate at the bitstream level rather than altering the content streams. You cannot assume that they're going to give you access to their content after it has been decrypted and decoded for you to patch it, because that violates the fundamental security model of all these transmissions. Okay, let's go to the next one. Okay, so for us, when this system hit the field, the issues we tested in the lab get much more complicated, right? And this is by our experience with working with Caritech on their deployment that you saw earlier. We were the company behind, the entire proof of concept, and that helped deliver the first few instances that are in production right now. So, for instance, jitter isn't just a random drift, right? It spikes unpredictably. Also, satellite impairments and IP congestion, they can and will happen at the same time. So that creates recovery patterns that we didn't anticipate during our testing or development. One of the toughest challenges, like I mentioned, is timing and sequence alignment between satellite feed and IP recovery. If it's not handled deterministically with a precise time measurement inside the device, you are going to have issues. Finally, last mile networks are completely dissimilar. So a device that works well in one location may not work well in another. So the hardware needs to be self-tuning and needs to adapt to both varying network and satellite conditions. So now let me walk you through how we tackled the challenges of hybrid workflows. First, with our MRTC, and then with the newer SAT hybrid receiver. The MRTC is a product we've launched a while back. It's been out for a while. It stands for Master Router Real-Time Clock. It was a solution that we developed to address the critical issue of timing instability in hybrid environments. We built it originally, among other things, to be able to bond together dissimilar networks, such as a Wi-Fi, a LAN, and a cellular, right? And bond them together. As timing was critical in this application, just like it is in hybrid satellite workflows, we made the MRTC generate its own local timing using a combination of GNSS and cellular, effectively making it a PTP/NTP time source. This ensures stable and reliable performance and alignment of buffers. So building on what we learned with the MRTC, we've now taken it a step further with the SAT hybrid receiver. This is essentially now the MRTC on steroids. We've added a custom buffer and recovery layer between the RF signal and the IRD, right? By doing it this way, it opens up a myriad of new applications for reliable transmissions over RF networks by the methods that you've seen explained in other presentations using the appropriate specifications. At the end of the day, manufacturers need to keep pushing to create hardware that doesn't just follow the old rules, right? The FPGA, put it out, you're done, but it's built to adapt to new challenges that constantly evolve. And that's exactly what we do. Okay. So to conclude, the takeaway here is, if you're a manufacturer in this space like we are, it's clear that hybrid workflows are fundamentally changing the way we need to design hardware. And if you're not adapting to these challenges, your products are already falling behind. But here's the thing. You can't just start over with every new trend. It's not about building a brand new product overnight, but about rethinking the way your hardware is designed, built, and deployed. It's about understanding the demands of modern workflows and evolving your approach to meet them. Is your product's software stack easily upgradable, or are you stuck because of your hardware design on whatever ships or whatever you can do? What we've learned at SipRadius is that the industry isn't waiting for perfect solutions. It's about creating an adaptable, flexible system that can grow with the new challenges. Manufacturers need to be in a constant state of innovation, adapting designs and anticipating what comes next. And thank you very much. I think you're on mute, Wes.
Thank you, Sergio. Just trying to be polite. You can go ahead and stop sharing.
Okay.
If all the other presenters can turn their cameras back on. And just we have a few minutes, a minute or two available if anybody has any questions from the audience. I think we've covered a lot of this stuff in great detail. Rick, I had a quick question for you. When and you're muted, just so you know. When do you think you're going to have to actually migrate off of C-band? What is your countdown clock?
Well, that's up to the FCC. I mean, one
Right.
thing that has been said to the FCC is that we believe, as the NAB has pushed to them, that they probably don't want to make any changes till after the LA Olympics. And that seems to have been well received by the FCC. Obviously, there's no telling exactly what will happen, but at this point, it could be anytime, in my view, after the LA Olympics. And it depends how much.
Refresh my memory.
Summer 2028.
Okay. So the auction has to take place by 2027, but
it has to be completed by July 4th, 2027.
Okay. July 4th. Interesting date.
Yep.
Okay.
It's the 2-year anniversary of the One Big Beautiful Bill Act.
Okay. Gotcha. All right. And an anniversary of something else that happened, I think, Alan, but okay.
Yeah. So once again, it's up to what happens to C-band is up to the federal government, and at this point, we can only wait and see.
Gotcha.
But prepare for the worst, which is C-band going away.
Understood. So, Ciro, I understand you guys are doing a lot of work in this area. Cobalt is busy making some new products and things like that. You want to take just a second to say what you guys are doing that you can talk about?
Yes, we are putting together a complete solution. We are adding satellite interfaces to our decoders, so you can have the same thing. The same decoder will do legacy and this stuff. And we're looking at providing basically a turnkey solution for this.
Great. Ruben, you mentioned that you've got some testing coming up. Is that something that you want to talk about in more detail? What's happening and when, maybe?
Yeah, we're exploring, multiple options and alternative. There is no, one solution fits all, and we're prepared to basically better understand everything. And in order to do that, we need to do a lot of testing and collect a lot of data. So we're going to start doing that early next year. And I hope that we can probably do another of these and come back with some results and share it with the community.
That would be great. And again, if anybody other than a speaker here wants to just jump in and talk for a minute, go ahead and unmute and ask a question.
I have a question for Sergio.
Go for it.
Would Part 7 be part of, or in the roadmap for Live RIST, will be part of that implementation at one point?
Oh, absolutely, yes. Yes,
okay.
And for those of you who don't know, LibRIST is the free, open, online. Sergio, you can describe it better, but
yes, it's an open source version, open source of the actual implementation of RIST, and it has a very liberal license so that anybody can use it for commercial purposes as well. There's no restrictions on how you can use the library, and it's built from production use. It's not just a POC that we give out. It's actually the core of our product as well. It's what we use inside SipRadius products. Unaltered, unmodified. We don't use a different version. Exact same thing that you find in the Git repositories.
Yeah, we're anxious, and anybody who wants to view that or distribute it, whatever, go to the vsf.tv website and you can see a link to get to those things, etc.
As a matter of fact,
Go ahead.
Richard from Caritech, he started building his entire solution just with the Libris library, and then he brought us in at the end to tie everything together.
Geez, I should have known that as speaking for him. Adi, real quick, you guys aren't directly in this space, but you're obviously providing tools that a lot of folks can use to better manage their networks and things like that. Is there anything that you want to just tell the audience about here real quick?
Yeah, thank you, Ace. I do want to mention everybody, it's been something that Ciro did mention. I started with this technology 5 years ago when it was to do with the first C-band auction and the 5G interferences. I gained a lot of field experience in a different position and different company. But I lended my experience to the RIST activity group, and that is going to come up with 3 different technical recommendations, the part 7, which we just discussed, part 8, which is going to be a non-intrusive implementation, which is much more sophisticated than the TR, and not touching the stream at all. And the part 8 that 7, 8, 9, that I described. What Alvalinks does, we provide visibility, we provide observability and visibility to the IP network, so that when you do a deployment, you know exactly where your feed is going through, what are the problems that they might come up with, and you have more visibility and ability to react to problems. Something that is missing in the industry today.
Sounds like something Ruben could use to reallocate his servers when they're needed for a big rain event or something like that. You could.
Indeed.
So I guess, Adi, you're going into the weather forecasting business, huh?
Well,
I do want to mention something that nobody touched based on, but it was alluded on something else. But the idea is using the hybrid approach, it allows you to save money at the end of the day. While the broadcast does cost money, the satellite costs money, the cost of the internet goes down significantly because you only commit bandwidth when needed as needed. So if you go into a cloud-based implementation using, let's say once AWS has a solution, or maybe Zixi, and they count all the bits and bytes of the recovery, it will significantly lower the operational costs for the users. So it makes a viable, cost-effective solution for people to start with. If they are not happy eventually with the satellite, maybe they will jump on the Zixi wagon or the Sergio wagons or the Cobalts going full-blown IP. But still, they have a way with this solution to test it, see how confident they can be, and save money while doing so.
Sorry, Adi. There's a fundamental trade-off between reliability, latency, and cost that has to be optimized. And nobody should underestimate how challenging it's going to be to replace C-band reliability for the cost. I mean, I think that was mentioned. However, couple of things. One is C-band is going to be reduced, period. So, there's nothing anyone can do about that. The other thing is that, there is a need for additional functionality that C-band cannot provide. And so that's the ability to regionalize and localize. And so it behooves everyone in the industry to work on a set of interoperable solutions that are flexible, and then manage the control of each receive site so that the cost, latency, and reliability can be optimized to meet the needs of each business. And KU band satellite is undoubtedly going to be one solution, but by no means will it be the only solution. And I think that's important for people to understand. And it's the ability to manage those, so that you can optimize what you need for the business that's really going to be important. And that's what we're focused on.
Yeah, very well said, Alan. I think, people are going to need multiple tools in their toolkit to be able to deal with, all of the evolving internet and IP transmission and other impacts that are going to be going on. And they'll be able to adapt to, better pricing as it comes along, pick up a new, data delivery mechanism and integrate it in. You need that flexibility. So,
yeah, and I can well see a scenario where KU band becomes a backup to
sure.
full-time terrestrial delivery, because you're delivering regional advertising. And okay, if the terrestrial links go out for whatever reason, then you take it from the satellite, and you don't have the regional capability but you're still on air. And so that's what I mean. It's got to be a flexible solution so that it can be configured to meet the business needs of the users.
Yep, absolutely. Very well said. So I'm not seeing any other questions. Just pause for 1 minute. Any other questions from the audience here? All right. Thank you very much for attending this RIST webinar. Really appreciate it. We'll have the recorded video from this posted in the near future, and it'll be available through the RIST.TV website. And I want to take this opportunity again to thank everybody for presenting, thank everybody for attending and listening to us. And I want to wish everybody a happy holiday season and a good start to 2026 when the new year rolls around. So for that, thanks everybody, and take care, and we'll talk to you soon. Bye-bye.
Thank you, Wes.
Thanks, everyone.
Wes. Thank you.
Great job, Wes.
Bye.
Take care.